Hello everyone, welcome to the lecture again. In the last lecture, we look at how do we analyze the structure. Particularly, we look at the planar truss and we look at method of joint. Today, we are going to solve two more examples on the method of joint. So, let us look at the first problem statement, and the problem statement is following: using the method of joints, calculate the force in each member of the truss shown, and you have to state whether each member is in tension or compression. So, to analyze the truss, first we have to make the free body diagram of the entire structure. You can see here that so let me first make the diagram. So, you have at point A, I have 160 kilonewton force that is acting, and then at point D there is again 160 kilonewton of force that is acting, and then at C you have a roller support and at point E you have a pin support. So, let us look at the reaction forces first. So, since at C you have roller support, so therefore, it will not support the vertical forces. So, you will have a force in the x direction, let us call it Cx, and at E you will have a pin support. So, therefore, it will support both the x component, so Ex and Ey. Now, let us see first whether this truss is statistically determinate or this is indeterminate. So, you can see that M, which is the member in the truss. So, let us count the member 1, 2, 3, 4, 5, 6 and 7. So, there are 7 members. Now, let us count how many joints are there. So, you have 1, 2, 3, 4, 5. So, there are 5 joints. And now, let us see the reaction forces. So, we have 1, 2 and 3. So, there are 3 reaction forces. So, you can see that M plus R is equal to 2J. Therefore, this truss is statistically determinate. That means, we can calculate all the forces or all the internal forces that are acting on the member of this truss. Now, to analyze the truss, let us first look at the free body diagram of the entire truss. So, free body diagram of the entire truss. So, we have this truss, the entire truss. Internal members we will not consider because we are looking at the whole truss. So, you have 160 kilonewton force acting at this point, and you have 160 kilonewton force which is acting over here, and here you have Ey, Ex, and then we have a force Cx. So, this is the free body diagram of the entire truss. Now, to calculate various forces, let us first take the moment about E. So, this point is E, this point is A, and this point is C. So, let me take the moment about E. So, Ex and Ey will not contribute in the moment because they are passing through E. So, we have Cx into 2 plus, because this is 2 meter, and 160 into 4, the first force, plus 160 into 2 equal to 0. So, this is the moment equation, and from here I can see that Cx is minus 480 kilonewton. So, this means that I have to change the direction of Cx. So, the Cx should act in that direction. So, Cx is 480 kilonewton and it should act in this direction. Now, summation Fx gives you Ex equal to Cx. So, this is 480 kilonewton, and of course, that should act in the opposite direction of the Cx. Now, Ey also I can calculate from summation Fy equal to 0 equation, and Ey will be 160 kilonewton plus 160 kilonewton, which is nothing but 320 kilonewton, and just to tell you its direction is upward. Now, all these parameters of Cx, Ex, Ey we got by considering the entire truss. Now, let us calculate other forces, other internal forces by using joint by joint. So, let us first look at joint A, the free body diagram of joint A. So, at A you have a force of 160 kilonewton which is acting downward. There will be a force along AB, and since I have to balance the horizontal force, let me put the direction like this. So, this force will be FAD. Now, let us say this angle is theta, and this theta of course I can find out from the geometry. Now, let me use the force balance equation along the y direction. So, summation Fy equal to 0. So, this gives you FAB sin theta equal to 160. So, therefore, FAB is 160 over sin theta, and this theta is that theta, and sin theta you can find out because this is 2 meter. So, therefore, this will be 1 meter, and therefore, this length will be square root 5. So, therefore, sin theta will be 1 over square root 5. So, let us put here. So, you get FAB equal to 160 square root 5, and this you can calculate. This is 357.77 kilonewton, and since its direction is away from point A or joint A, so therefore, this will be a tensile force. So, for tensile, let me just write down T. Okay. So, this T stands for tensile. Now, let us use another equation, summation Fx equal to 0. So, you have FAB cos theta equal to FAD, and FAB is 160 square root 5 into cos theta is 2 over square root 5 equal to FAD, and this gives you FAD equal to 320 kilonewton. Now, this force is acting towards A. So, therefore, this will be compressive force. So, therefore, let me write down C. Now, let us use joint D. So, the free body diagram of joint D is like this. You have a 160 kilonewton force that is acting downward, and then you have a force which is acting upward FDB, then you have the force FDE and you have the force of AD which we have just calculated. So, FAD, this is nothing but 320 kilonewton and this is point D. So, you can again use summation Fx equal to 0, summation Fy equal to 0. So, immediately we get FDB equal to 160 kilonewton, and since it is away from the joint, so therefore, this is tensile and FDE is 320 kilonewton, and since it is acting towards point D, so therefore, this will be the compressive force. So, now let us look at joint E. At joint E, we have the Ex and Ey forces. So, this Ex and Ey forces which we have already calculated. So, this is 480 kilonewton and then we have 320 kilonewton. Now, there will be a force from D to E which we have calculated. So, this was 320 kilonewton DE force, and we have a force from C to E. So, let us call it FCE, and we have a force from BE. So, let me put it like this FBE. Let us say this angle is theta. So, what we are saying is this angle is theta. So, therefore, I can find out what is the value of cos theta and sin theta, etc. Now, let us balance the equation along the x direction. So, summation Fx equal to 0. So, we have FBE cos theta plus 320 equal to 480. So, this gives you FBE equal to 160 over cos theta. This is 160 divided by 2 is square root 5, and this comes out to be 178.9 kilonewton. And from the direction, it is clear that it should be a compressive force. Now, let us use summation Fy equal to 0. So, you get FCE plus FBE sin theta equal to 320. So, we have FCE plus 178.9 into sin theta is 1 over square root 5 equal to 320. So, therefore, FCE is equal to, so you can simplify it, this will be 320 minus 178.9 divided by square root of 5, this comes out to be 80 and this will give you 240 kilonewton, and again it will be the compressive force. Now, to analyze further, let us look at joint B. So, we are going joint by joint. So, first we analyze point A, then point D, then point E. Now, let us look at point B. So, joint B, let us make the free body diagram of this joint. So, at B you have 160 kilonewton force which is acting downwards, then there is a force of FBA which we have calculated. So, FBA is 357.77 kilonewton. Then we have the force FBC and you have a force FBE which again we have calculated. So, FBE it was 178.9 kilonewton, and from here we can find out what is the value of BC. So, let us look at the geometry. So, this angle we have find out that this angle is theta. So, if this angle is theta, therefore, this angle will also be theta, and again from the symmetry this will be theta and that will be theta. So, let us balance the force along the x direction. summation Fx equal to 0. So, we have F B C cos theta equal to 357.77 cos theta plus 178.9 cos theta. Now, cos theta you can already you can find out. So, F B C will be 536.7 kilonewton and it will be the tensile force. So, now let us look at the last joint, which is joint C. So, at C we have the force which will be along CE. So, this force we have already calculated, this is 240 kilonewton, and just now we calculate the force BC. So, this will be along this direction and its value will be 536.7 kilonewton, and from the horizontal, let us say it is making an angle theta. In this direction we have a 480 kilonewton of the force. So, this will be C x force, which we already know that 480 kilonewton. So, now let us use the force balance along the x direction. So, here we do not need to find anything because all the parameters are given. So, let us see whether summation Fx and summation Fy equation is satisfied for joint C or not. So, let us use summation Fx equal to 0. So, we have 536.7 cos theta equal to 480 kilonewton, and this cos theta we have already find out, this is 2 divided by square root of 5, and you calculate that it comes out to be 480 kilonewton. So, therefore, this and this is satisfied. Similarly, you can also see that summation Fy equal to 0 is also satisfied. So, with this we have calculated all the forces that are acting on the joint. Now, let us look at the second example. So, this is another truss, and here the problem statement is following: using the method of joints, determine the force in each member of the truss. So, first of all, since you have asked to find out the force in each member, so therefore, anyway we have to use the method of joint. So, let us see here. So, here you have this truss, so this point is A, B, C and D and E. Now, at point E you have a roller support. So, therefore, it will support the force only in the y direction, so only EY. At point C you have a pin support. So, therefore, there will be a force along x direction. So, let us call it Cx, and then there will be a force in the y direction. So, let me call it Cy. Now, you can see that the total number of member are 1, 2, 3, 4, 5, 6 and 7. So, there are 7 members and there are 1, 2, 3, 4, 5. So, there are 5 joints and total reaction forces are 3. So, again we see that M plus R is equal to 2J. That means, this truss is again statistically determinate. Statically determinate truss. Now, to analyze as we did earlier, let us consider the free body diagram of the entire truss, which is given here, just that I have to put the forces. So, let me put the forces. So, free body diagram of the entire truss. Okay. So, again we have this truss, this point is A, B, C, D and E. At E you have EY force, at C we have CX and CY force. Now, at point A I have a force of 10 kilonewton, here I have 5 kilonewton force, and this is 6 meter, this is also 6 meter, and this distance is 3 meter, this is 6 meter and this is also 3 meter and this one is 4 meter. To analyze this truss, let us take the force balance equation. So, from here you can see that Cx is not balanced. So, therefore, summation Fx gives you Cx equal to 0. Okay. So, summation Fx equal to 0. So, there is nothing to compensate for Cx. So, therefore, Cx will be 0. Now, let us take the moment about C to find out what is the value of Ey. So, if I take the moment about C, then Cx and Cy will go away and I will have Ey into the perpendicular distance is 3 meter equal to 5 into perpendicular distance is 6 plus 10 kilonewton force multiplied by the perpendicular distance which is 12 meter, and this gives you Ey equal to 50 kilonewton. Now, let us balance the force equation in the y direction also. Summation Fy equal to 0. So, this gives you 10 kilonewton plus 5 kilonewton equal to Ey plus Cy, and Ey we have already calculated, it is 50. So, therefore, Ey is 50, therefore, Cy will be minus 35 kilonewton or Cy will be 35 kilonewton, but we have to change the direction. So, let us change this direction downwards. So, now to further calculate, let us look at each point. So, let us look at joint by joint. So, let us look at joint A, the free body diagram of joint A. So, we have point A. On this point we have a external force of 10 kilonewton, then there will be force along AB and there will be a force along AD. So, since I have to balance that 10 kilonewton force downward, so let me put the force direction like that, and this will be FAD. Let us say this is making an angle of theta. So, what I am saying is this angle is theta. So, you can find out what is the value of cos theta and sin theta, because this is 4, this is 3. So, therefore, this will be 5 and cos theta will be 4 by 5. So, let us balance the force along the y direction, summation Fy equal to 0. So, we get 10 equal to FAD cos theta, 10 equal to FAD, and cos theta is 4 divided by 5. This gives you FAD equal to 12.5 kilonewton force. And you can see that this force is compressive because it is towards the pin. Now, let us balance the force along the x direction. So, summation Fx equal to 0. So, we get minus FAD sin theta plus FAB equal to 0. So, this gives you FAB equal to 12.5 into sin theta. Sin theta is 3 divided by 5 and this comes out to be 7.5 kilonewton, and this is the tensile force because it is acting away from point A. Now, let us look at joint D. So, let us make the free body diagram of joint D. So, we have point D and we have a force that is acting along AD. So, we have F dA and its value we have already calculated, it is 12.5 kilonewton. So, let us put the other force F dB and F dA, and let us say these angles are theta. So, again you can find out what is theta. So, what we are saying is this angle is theta and this angle is also theta, and cos theta and sin theta I can find out because this is 3 and the other length is 4. So, let us balance the force along the y direction. So, summation Fy equal to 0, and from the symmetry you can see that F dB will also be 12.5 kilonewton and it is tensile. Now, let us balance the force along the x direction. So, you have F dE equal to 2 into F dA sin theta. So, this is 2 into 12.5 into 3 by 5, this comes out to be 15 kilonewton, and this is compressive. Okay. I have taken 2 here because FDA and FDB is already, they are equal. So, either you write down it again or just multiply by 2. So, with this we have solved joint D. So, now let us look at the next joint B. So, at B we have an external force of 5 kilonewton and then you have FBC and FBA which we have already calculated, this is 7.5 kilonewton, and then there are two forces FBD which we have calculated, this is 12.5 kilonewton, and then FBE. Now, to calculate it, let us again say that these angles are theta and theta we know. So, let us use the force balance along the y direction, summation Fy equal to 0. So, this gives you minus 5 minus 12.5 cos theta minus FBE cos theta equal to 0. This gives you FBE equal to minus 5 minus 12.5 into cos theta is 4 by 5 and divide by cos theta which is again 4 by 5. So, this comes out to be minus 18.75 kilonewton. So, that means we have to change the direction of BE. So, this force should be in that direction, and therefore, this is a compressive force. Now, let us balance the force along the x direction, summation Fx equal to 0. So, we have minus 7.5 plus FBC minus 12.5 sin theta minus 18.75 sin theta equal to 0. Now, we know all the sin theta. So, from here FBC comes out to be 7.5 plus 12.5 into 3 divided by 5 plus 18.75 into 3 divided by 5, and this is 26.25 kilonewton, and you can see that this is a tensile force. Now, let us look at the last joint which is joint E. So, at E you can see there is a force of 50 kilonewton. This is the reaction from E towards y direction, and we have a force along DE which we have already calculated. So, this is 15 kilonewton. We have also calculated the force along BE, it is 18.75 kilonewton, and then the force along C. So, this is F EC. Now, let us say this angle is theta. So, let us balance the force along the x direction. So, summation Fx equal to 0. So, you have 15 plus 18.75 sin theta plus F EC sin theta equal to 0. So, this gives you F EC equal to minus 15 minus 18.75 into 3 divided by 5 divided by sin theta, which is 3 by 5. This gives you minus 43.75 kilonewton. This means that we have to change the direction of EC. So, with this we have calculated all the forces, and you can check by yourself that summation F y equal to 0 equation is already satisfied, and this confirms that all the forces that we have calculated is correct. So, with this let me stop here. In the next class we will look at the method of sections. Thank you.